Okay, this is question number 13. The curve C has parametric equations. X equals 2 cos t, y equals root 3 cosine 2t, where t is greater than or equal to 0, but less than or equal to pi. Part A, find an expression for dy by dx in terms of t. Easy question to get us going here. So dy by dx. Now, in terms of parameters t, we need a dy by dt. What do we multiply that by? Well, we multiply that by dt by dx, don't we? Okay. So we need to find dy by dt. That's probably the easiest one to find. So dy by dt. Well, differentiate that. We get minus 2 square root 3, and that will differentiate sine, won't it, of 2t. So we find dy by dt. Now dx by dt is the trickier one. Dx by dt, well, don't forget dx by dt is 1 over dt by dx, but we've got it in x equals something, so this should be very easy to differentiate. We get minus 2 sine of 2t. Or just sine of t in it, because there's nothing in front of the cosine t bit, is there? So, yeah. Okay. So that is dy by dt and dx by dt. So dy by dx then is minus 2 square root 3 sine 2t, and divide that by minus 2 sine of t. The minus 2's will cancel out, so we get root 3 sine of 2t all over sine of t. Now, we know a formula for sine of 2t. Well, we should. Whether we remember that formula is a totally another story, isn't it? So if you do remember it, you'll remember that sine 2t is 2 sine t cosine t. So substituting 2 sine t cosine t in, we get root 3 multiplied by 2 sine of t cosine of t. Divide that by sine of t. You'll see that those signs will go. So I just get 2 times root 3 cos t. So 2 square root 3 cosine of t. Okay, and that is part A. Okay, part B. We'll look at part B then. Part B says the point P lies on C where t is 2 pi over 3. The line L is the normal to C at P. Part B, show that an equation for L is 2x minus 2 root 3y minus 1 equals 0, 5 marks. Right, this is a lot of work here for 5 marks, so we need x when t is that 2 pi over 3. Now, on your calculator, it will do that for you. That's 2 lots of cosine of 2 pi over 3, which is minus 1. Okay, just because don't forget that 2 pi is 3/60, so it's cosine of 120 multiplied by 2. So we get minus 1. Okay, you got to be careful with that one. We also need the y when t is 2 pi over 3. And that is minus root 3 over 2, doing that on your calculator. Okay. So we know the point P now. We know the point P has minus 1 minus square root 3 over 2. Okay, that's helpful. So dy by dx when t is 2 pi on 3, which is minus square root 3, which is the gradient of the tangent. So the gradient of the normal then will be minus 1 over that, so that will be just 1 over root 3, won't it? So we get y minus minus, so it becomes a plus square root 3 over 2. is equal to 1 over square root 3, the gradient, of x plus 1. Rearrange, we get root 3y plus 3 over 2 is x at 1. Yeah, and then getting everything equal to 0, we get 2x minus 2 square root 3y minus 1. Just multiplying by 2. Get 2x plus 2, rearranging, and you get to that. Okay, as required. End of proof. Okay, so that's part B. 5 marks for that. It's a generous 5 marks, if I do say so myself. Okay, part C then. The line L intersects the curve C again at the point Q, finding the exact coordinates of Q. Now, if you do other examples, you'll know that this rarely comes up, but it's a good parametric equations question because it tests your actual knowledge for this question on part C. So basically, we want to solve that equation of the line, replacing with x is 2 cosine 2t, and see what we get, and the y bit as well. So we'll substitute in it, we get 0 is 4 cosine of t, don't we? Now that'll be minus 6 cosine 2t, and I take away the 1. Now cosine 2t, we have a formula for, cos squared minus sine squared, substituting in the sine squared, or the cos squared, will get you into the other rearrangement using sine squared plus cos squared is 1. So we get 4 cosine of t minus 6 lots. Now I'm going to use the 2 cos squared t minus 1, take away 1, which is 4 cosine t. That'll be minus 12 cos squared t once it multiplying out the bracket, minus 6, and that'll be, that's plus 6 minus 1, which is plus 5, and like that. I don't fancy leaving that as it is, so I'm going to put that in a nicer form, getting the coefficient positive. So get 12 cos squared t minus 4 cosine t minus 5 is equal to 0. I want to solve that. I don't think it'll factorise. I mean, we could try it, but I don't think it will. We could try it by looking at our numworks calculator. So on the numwork calculator, to solve this, you're going to need to go to equations. In fact, if we go to calculation and we put it in as we see it, so we get 12. Where's the button go? I've lost the button. Lovely. That's the x. 12x. That should be a power of 2. Minus 4x. For some reason, it don't want to solve it. So put 12 negative 4 and a negative 5. It will solve my quadratic equation. Okay, solve. So I get x is minus a half and x squared is 5/6. And that's the one I want to use, don't I? So I want to use that second one. This x2 value I want to use 5/6. So we get cos of 2t being that 5/6. And the other one was cosine t being minus a third, wasn't it? That should be not a 2, that shouldn't be there. It should be cos t, wasn't it? So inverse cos then of 5/6. Back to the calculator. Go to the home menu, calculations. If we do everything in there, so we do shift inverse cosine of 5/6, which is 33.55 degrees. And I don't want that in degrees, I'd like it in radians. So and that is what? Like 0.5856. I think I can do it with. Doing that on my other calculator instead of using the online calculator. So we've got t is that. So x then is 2 lots of 5/6, which is just 5/3. So we're ending up with y being equal to root 3 times by, subbing into the original, 2 lots of 5/6 squared minus 1. Which, doing that here on my other calculator, got me to 7√3/18. Okay. So therefore Q is 5/3 and 7√3/18. Okay. And that is how we can get the full marks here on question number 13.